Video will discuss about the design of mux. Okay, so design of mux starting from 2 to 1 mux, 4 is to 1 mux, and 8 is to 1 mux. Okay, so first, what is the black box diagram for the 2 to 1 mux? Okay, 2 to 1 mux. So black box for 2 to 1 mux. So how many slide signals for 2 to 1 mux? Only one. I naught and I1. So mux 2 to 1. This is the out. So draw the black box. Okay. So what is the first the circuit diagram for the mux 2 to 1. So next what is the truth table for the mux? Yes, out. So if S is, it may be 1 or 0. If S is 0, I0 will be transmitted. That is what is the mux concept? Many to one concept. So if S is the I naught, for example, the two channels are transmitted, so are multiplexing together and transmitted, okay, via single channel. So the I naught, I1, so the I naught may be either, you can set either 0 or 1, whatever you want to transmit. I1 you can transmit 1, 0, 1, 0, okay. So any data can be transmitted via I naught and I1. The multiplexing concept generally multiple channels are connected or multiplexed together, combined together, okay, and transmit via a single wire, a single channel, maybe wired or wireless. So many to one concept, many to one concept. So if S is 1, I1 will be transmitted. Now this is the truth table. So you can represent this truth table in a different ways. So different modeling styles. So what are the different modeling styles? First one is the behavioral modeling style. So you can say data flow modeling, then gate level modeling, structural modeling, switch level modeling. So any one of the modeling you can write the code. So here you can different ways. See the out you can write. The rest of the truth table you can write. Okay. So out is equal to, so if S is 0, I naught will be transmitted. S is 1, I1 will be transmitted. Okay. So you can write S bar I naught plus S1 S S bar means 0 S I1. Either this way also you can write. Sorry. And write S bar I naught. So this is the R symbol. Put the R symbol. This is the AND symbol. So neg of S. Okay, and I naught. R symbol in Verilog. S. Okay, S and I. So you can write this way also. Assign using data flow modeling, you have to add assign statement. Assign out is equal to neg of S and I naught or S and I1. So this way data flow also you can write. Okay. Here one of the behavioral statement. we'll discuss with the special operator is called ternary operator. Ternary operator. What is a ternary operator? Or it is called conditional operator. So what is the conditional operator? It says true condition and false condition. Okay. So here uh, ternary operator or conditional operator. So how you can write the coding by using ternary operator for 2:1 max? You can write with respect to the truth table. Okay. Assign out is equal to if S with respect to the truth table, if S is true, then I1 will be transmitted. If S is false 0, I0 will be transmitted. Okay. So this is a way to write the 2:1 mux using conditional operator. How to write the code I'll tell you. So this is the concept. Similarly, next 4:1 mux. So for 4:1 mux, my mux name is 421. So how many select signals for the 4:1 mux? S0, S1. How many input lines for 4:1 mux? I0, I1, I2, I3. In multiple bits, you can go for the vector declaration. Okay, this is out. So now this is the black box. So always I ask you to draw the black box, which is helps to write the top level model with the proper IO specifications. You can specify all the inputs and outputs. Okay. So for 4:1 mux, so using if you want to, so first what is the truth table? We will see here truth table S1, S0, then out. So it may be 0, 0. The first signal may be either 0, 0, 0, 1, 1, 0, 1, 1. Okay. So the out, if both are 0, 0, I0 will be transmitted. If both are 0, 0 means I0 will be transmitted. If 0, 1, then I1 will be transmitted. Okay. If 1, 0, I2 will be transmitted. Okay. If it is 1, 1, then I4 will be, I3 will be transmitted. So I0 will be transmitted, I1 will be transmitted, I2 will be transmitted, I3 will be transmitted. If you want to write the coding, so by using Verilog HDL, the Verilog constructs using again if you use same conditional operator. So you know what is conditional operator. So here if first if take S1, this is false and this is true condition. If S1 is true, okay, if S1 is true, you would consider these two. If S1 is true, so you can write the coding out is equal to, okay, if S1 is true, question mark, open the bracket, then you check the next one, that is this color. Okay, I'll take this color, this color I'll take. Okay. Take next you check S not. Okay, inner loop. So the outer first you check S1, that is true or not. So if it is true, then you check S not. If S naught is true, true means 1. If check S naught is true, then which one will be transmitted here? Okay. If S naught is true, then if S naught is true, if S naught is true, I3 will be transmitted here. Else means false. Then I2 will be transmitted. Understand? Over. The next one, if S1 is false, if S1 is false, so you can write here, if S1 is false, then you check, okay, S naught. In that case, if S naught is true, I1 will be transmitted, yes, I naught will be transmitted. False condition means 0. I naught will be transmitted. Okay. So this is a 4:1 mux using ternary operator. Similar way using conditional operator you can write for 8:1 mux also. Okay. So we'll see side by side how to write the coding also. Okay. Then so how do you write the coding here? For example, for 2 to 1 mux is a 4 to 1 mux and 2 to 1 mux. For 2 to 1 mux, if you want to write the code, see module. What's the model name? I given the model name is my mux 221. So module mux 221. So specify the outputs first, followed by the inputs. The two inputs are I, comma S, end with semicolon. First, you practice how to write the coding on your notebook. Then you can use the tools. Understand the concepts. So declare the outputs. Output. What is the output here? Out. Inputs are input I, comma S. So this is scalar only here. So what is the two inputs? No. So wait. How many inputs? Two inputs. Okay. Input 1 down to 0. I0, I1. Okay. Then input, yes, scalar. So scalar declaration. Then you can body of the program. You can use any modeling. Either behavioral modeling you can do or data flow modeling you can do. Whatever model. So data flow model. Straight away you can write assign out equal to if. So assign out equal to if S is true, then you have to transmit I of 1, because see array declaration, if you want to retrieve the individual, but you use I square bracket 1, else I of 0 will be transmitted. Okay, with respect to this 2 to 1 mux truth table, you are writing the I0. So end with the semicolon. That's model and model. Same you can write for the 4 is to 1 max. So for example, if I write the code here, module max 4 to 1, open the bracket, output, seeing one output, out followed by the inputs, I are the inputs. So why I am declaring I am going to declare as a vector because multiple bits I comma s. So output, you have to declare the ports, output out. Okay, so these are the keywords. Then input, again this is also for keyword. This is the input. The module name, you have to declare the output out, input. Okay, so how many inputs? 3 down to 0 I, because I0 I1 I2 I3. Then input S. What about S for 4 is to 1 max? 4 to 1 max. So how many inputs? 4. How many select signals? S is 2 select signals. So 1 down to 0 S. What is the meaning of this declaration? S0 and S1. So this is the truth table. This is a diagram. Black box, truth table, and how to write the code. Then again you can use the same ternary operator. Okay. Assign. So assign is a keyword. Assign out equal to, assign out is equal to, if, so you write the same here. If S1 is, so what is the meaning of this one? If S1 is true, you check S0. S0 is true, transmit I3, else I2. Else, if S0 is false, S1 is false, then again check S0. S0 is true, I1 will be transmitted, else I0 will be transmitted. Okay, then N. N node. Okay, so 2 to 1 max, 4 to 1 max over. Then 8 is to 1 max, we'll see. So what is 8 is to 1 max? So now you design 8 to 1 max using 4 to 1 and 2 to 1 using structural modeling. Using structural modeling. Okay. So this for structural modeling, you should know the complete circuit diagram and the concept. So the truth table, next to truth table. How many select signals for 8 is to 1 max? For 8 to 1 max, there are 3 select signals. 3 select lines are required. So S2, S1, S0. Okay, the black box diagram. This is a black box diagram. So 3 select signals, S0, S1 and S2, and I0, I1, I7. This is max A to 1. So I am giving my model name starting with the alphabets, not with the numerals. So this is out. So draw the black box. You want to avoid the confusion, draw the black box. Okay. So yes now. So now truth table, black box over, truth table for 8 is 1 max out. So what is the truth table says? 0 0, I0 will be transmitted. It is 0 0. So 0 0, I0 will be transmitted. 0 0. This 0 0 1, Okay. Mm, this one I1 will be transmitted. Okay, like that. If it is 1111, I7 will be transmitted. I7 will be transmitted. So this is the concept of 8 is to 1 mix. So 00 I0 will be transmitted. If it is 001, I1 will be transmitted. 010, 011, 100, 101, 110, 111. The different combinations I2, I3 channels, for example, I4, I5, I6, I7. So in a lab record for 2 to 1 max, 4 is to 1 max, 8 is to 1 max, the necessary circuit diagram, truth table, and the concept. So now, if you want to write any code by using behavioral model, using ternary operator, assign statement, data flow operator, data flow modeling using assign operator, you can write. So here we will